For as long as humans have looked up at the night sky, one object has always stood out. A faint red light, slowly drifting among the stars, glowing with a mysterious intensity. Ancient civilizations believed it was a god of war, a symbol of fire, or an omen of disaster. But today, we know it by a different name, Mars. Yet even now, despite everything science has taught us, Mars continues to hold a special place in the human imagination. It is not just another planet. It is the one world in our solar system that feels almost reachable. It is close enough to dream about, yet distant enough to challenge everything we know about survival, technology, and the limits of human ambition. Mars is more than a scientific target. It is a mirror of Earth's past, a warning of what our own planet could become, and perhaps the only realistic place where humanity might one day build a second home. But to understand why Mars matters so much, we first need to understand what it actually is. Mars is smaller than Earth, with about 38% of our planet's gravity. That means if you stood on its surface, you would feel lighter, as if your body had lost more than half of its weight. You could jump higher, move faster, and fall more slowly. But that same low gravity comes with a cost. Over long periods of time, it can weaken bones, damage muscles, and alter the human body in ways we do not fully understand. The planet's atmosphere is another major difference. Mars has one, but it is incredibly thin, about 1% as thick as Earth's. It is made mostly of carbon dioxide, with almost no oxygen and very little pressure. Step outside without a spacesuit, and you would not suffocate the way you do underwater. Instead, the lack of pressure would cause the fluids in your body to boil. Within seconds, you would lose consciousness. Within minutes, you would be dead. Temperatures on Mars are equally brutal. At the equator, on a warm summer day, the surface might briefly reach about 20 degrees Celsius, similar to a cool day on Earth. But at night, temperatures plunge to -70 or lower. Near the poles, they can drop below -100 degrees. This is a world of freezing deserts, not flowing oceans. And yet, Mars was not always like this. Billions of years ago, Mars looked shockingly similar to Earth. It had rivers, lakes, and possibly even oceans. It had a thicker atmosphere, a stronger magnetic field, and a climate that could support liquid water for long periods of time. In other words, it had the basic ingredients for life. Then something went terribly wrong. Mars is small, and because of that, its core cooled faster than Earth's. As its interior cooled, its magnetic field weakened and eventually disappeared. Without that magnetic shield, the solar wind, a stream of charged particles flowing from the sun, began to strip Mars' atmosphere away. Over millions of years, the air thinned. The pressure dropped. Water on the surface either froze, evaporated, or was lost to space. The planet slowly transformed into the cold, dry desert we see today. Mars is not just a dead world. It is a fossil. It is a snapshot of what happens when a planet loses its protection and its ability to hold on to heat and air. That is one reason scientists are obsessed with it. By studying Mars, we learn what keeps Earth alive and what could one day threaten it. But there is another reason Mars matters so deeply. It is the only place beyond Earth where humans could realistically survive. Venus is far too hot, with crushing pressure and clouds of acid. The gas giants have no solid surface. Their moons are interesting, but they are far from the sun and buried beneath ice. Mars, by contrast, is cold but not hopeless. It has water locked in ice. It has a day almost as long as Earth's. It has seasons. It has sunlight. It has the raw materials needed to build, breathe, and possibly grow food. In the vast emptiness of space, Mars stands out as the one world that almost feels like a second chance. But dreaming about Mars is easy. Going there is something else entirely. Mars is not just far away. It is separated from us by a hostile, deadly void. Depending on where Earth and Mars are in their orbits, the distance between them can range from about 55 million kilometers to over 400 million kilometers. Even at its closest, Mars is farther away than any place humans have ever traveled. Reaching it requires months of travel through deep space, where there is no air, no gravity, and no protection from cosmic radiation. Astronauts would be exposed to high-energy particles that damage DNA, increase cancer risk, and slowly degrade the human body. They would be confined inside a small spacecraft for half a year or more, with no escape, no rescue, and no margin for error. And when they finally arrive, they will not be stepping onto a friendly new world. They will be stepping onto a planet that is actively trying to kill them. Mars has no breathable air, no natural protection from radiation, no liquid water on the surface, no plants, no animals, and no ecosystems to support human life. Every breath, every sip of water, every bite of food will have to be manufactured, recycled, or extracted from the environment by machines. A colony on Mars would not be a town. It would be a fragile life support system, buried beneath layers of metal and rock, constantly fighting against vacuum, cold, and radiation. And yet, despite all of that, people are still determined to go. Because Mars represents something much bigger than a planet. It represents survival. It represents the idea that humanity does not have to remain trapped on one vulnerable world, that we can learn to live beyond Earth, that we can become a species that belongs to the solar system, not just to one fragile blue dot. But is that dream realistic? Or is Mars just another beautiful illusion waiting to break? That is where the real story begins. The moment humans set foot on Mars, the planet will make one thing brutally clear. This is not a place that wants us there. Every part of the Martian environment is hostile to human biology. There is no breathable oxygen, no protective magnetic field, and no thick atmosphere to shield us from deadly radiation coming from the sun and deep space. Mars is beautiful from orbit, but on the ground, it is one of the most dangerous places a human could ever stand. On Earth, our atmosphere acts like a powerful shield. It blocks harmful radiation, keeps temperatures stable, and allows liquid water to exist. Mars has almost none of that. Its atmosphere is so thin that it provides very little protection. Astronauts on the surface would be exposed to levels of radiation that would dramatically increase their risk of cancer, damage their nervous systems, and weaken their immune systems. Over time, this exposure could become fatal. That is why any long-term human presence on Mars would need to live underground. The surface is simply too dangerous. Colonists would have to dig into the soil, using the planet itself as a protective blanket against radiation and extreme temperatures. Their homes would look less like futuristic cities and more like buried bunkers. And those bunkers would need to be airtight. Mars' atmospheric pressure is so low that without a pressurized suit or habitat, the human body cannot survive. Water in your blood would begin to boil, not because it is hot, but because there is not enough pressure to keep it in liquid form. Your lungs would not be able to absorb oxygen. You would pass out in seconds. So every structure on Mars would need to be sealed, pressurized, and constantly monitored. A tiny leak could be a death sentence. Every door, every valve, every pipe would have to work perfectly all the time. Then there is the problem of temperature. Mars is a frozen desert. Even on its warmest days, it is far colder than anything most humans have ever experienced. At night, the temperature can drop so low that metal becomes brittle and electronics struggle to function. Heating a habitat on Mars would require enormous amounts of energy, all day, every day, forever. That energy has to come from somewhere. Solar power is an option, but Mars receives less sunlight than Earth. Dust storms can block the sun for weeks or even months at a time, turning the sky into a red haze. During those storms, solar panels become nearly useless. That means a Mars colony would need massive batteries or nuclear reactors to survive when the sun disappears. Food is another enormous challenge. On Earth, we take farming for granted. Plants grow in soil, rain falls from the sky, and sunlight is abundant. On Mars, none of that exists naturally. The soil is toxic, filled with chemicals that are harmful to humans and plants. There is no rain. The air is unbreathable. If you want to grow food, you have to create an artificial earth inside a sealed box. That means greenhouses with controlled temperature, humidity, pressure, and lighting. It means recycling every drop of water. It means carefully managing nutrients. One failure in that system could wipe out an entire harvest, and when you are millions of kilometers from Earth, you cannot just order more supplies. Water itself is a precious resource. Mars does have water, but almost all of it is frozen in ice, either underground or in polar caps. To use it, colonists would have to drill, melt, and purify it. That takes energy, equipment, and time. Every glass of water on Mars would be the result of machines working nonstop to extract it from a frozen, hostile world. Even the air people breathe would have to be manufactured. Mars' atmosphere is mostly carbon dioxide. Colonists would need to use chemical processes to separate oxygen from CO2, producing breathable air. This is possible, but it requires power and machinery. If those systems fail, there is no backup atmosphere waiting outside. And then there is the human factor. Living on Mars would mean living in extreme isolation. A small group of people, trapped inside metal and rock, knowing that Earth is months away and that no rescue is possible. Communication delays mean that conversations with Earth would be slow and frustrating. If something goes wrong, colonists must solve it themselves. Psychologically, this is incredibly demanding. People need open spaces, nature, and social connection. Mars offers none of that. Every tree, every patch of grass, every breath of fresh air would have to be artificially recreated inside a habitat. This is not just a technical challenge. It is a test of human endurance, cooperation, and mental health. So why do it? Why would anyone choose to live in such a place? Because Mars is not just about comfort. It is about survival. It is about learning how to live off Earth, how to build closed systems, how to recycle everything, how to survive on another world. These are the skills that could one day allow humanity to spread through the solar system. Mars is not the destination. It is the training ground. But can we really make it work? That is the question that scientists and engineers are trying to answer right now. When people imagine humans living on Mars, they often picture something much more optimistic than underground bunkers and sealed habitats. They imagine green fields, blue skies, flowing water, and open cities. They imagine Mars transformed into a new Earth. This idea has a name: terraforming. It means changing an entire planet so it can support human life naturally. On paper, terraforming sounds exciting. If we could thicken Mars' atmosphere, warm the planet, and give it liquid water, humans could walk outside without bulky suits. Crops could grow in the soil. Rivers could flow. Mars would become a true second home for humanity. But here is the harsh truth. Terraforming Mars is not just difficult. It is one of the most extreme engineering challenges imaginable. It goes far beyond building rockets or habitats. It requires changing the entire physics and chemistry of a planet. The first problem is the atmosphere. Mars has almost no air. Its atmosphere is so thin that it cannot trap heat or protect the surface from radiation. To make Mars habitable, we would need to create a thick atmosphere, rich in oxygen and nitrogen, similar to Earth's. Where would that atmosphere come from? Mars does not have large reserves of free gas waiting to be released. Some carbon dioxide is frozen in the polar ice caps and trapped in the soil. But even if we released all of it, it would only make a small difference. It would not create anything close to Earth-like pressure. To build a real atmosphere, we would need to bring in massive amounts of gas from somewhere else, possibly by redirecting comets or mining other planets. The amount of material required would be astronomical. We are talking about moving trillions of tons of matter across the solar system. That alone is far beyond anything humanity has ever attempted. Then there is the temperature problem. Mars is cold because it is farther from the sun and because its thin atmosphere cannot trap heat. Even if we added more carbon dioxide to create a greenhouse effect, the warming would be limited. Mars does not have enough gravity to hold a thick, warm atmosphere for long periods of time. Over millions of years, the gas would slowly leak into space. And that brings us to one of the most important issues of all. Mars has no global magnetic field. Earth is protected by a powerful magnetic shield that deflects solar wind. Without it, our atmosphere would slowly be stripped away by the sun. Mars lost its magnetic field billions of years ago, and that is one of the main reasons it lost most of its atmosphere and water. If we somehow gave Mars a thick atmosphere today, the sun would begin stripping it away tomorrow. To truly terraform Mars, we would need to give it a magnetic field. That means creating a planetary scale magnetosphere, something no civilization has ever done. We would need to generate a magnetic field strong enough to wrap around an entire planet and protect it from solar radiation. This is not just engineering. This is planetary level physics. Even if we solve the atmosphere and temperature problems, the soil on Mars presents another obstacle. Martian soil contains toxic chemicals called perchlorates. These substances are dangerous to humans and deadly to most plants. To grow crops directly in Martian soil, we would need to remove or neutralize these toxins across vast areas of land. That would require enormous industrial operations running for decades, maybe centuries. And even after all of that, Mars would still be a weaker, harsher version of Earth. Its gravity is only about 1/3 of Earth's. Over long periods, low gravity can cause muscle loss, bone weakness, and other health problems. We do not even know if humans can live healthy lives under such conditions. So terraforming Mars is not a matter of a few bold projects. It is a process that would take hundreds or thousands of years, massive energy resources, and technologies that do not yet exist. In other words, Mars will not become Earth anytime soon. That does not mean it is useless. Mars is still incredibly valuable scientifically. It holds clues about the history of our solar system and the possibility of life beyond Earth. But turning it into a true second home is far more difficult than most people realize. So if Mars cannot be easily terraformed, and if living on its surface is incredibly dangerous, what does that mean for human missions? It means that any human presence on Mars would be fragile, expensive, and constantly at risk. And that brings us to the biggest question of all. Is it actually worth it? When people talk about sending humans to Mars, they usually focus on technology, rockets, spaceships, spacesuits, habitats. But there is another force that matters just as much as physics or engineering: money. And when you add up everything required to get humans safely to Mars and back, the numbers become almost unbelievable. A single human mission to Mars is not just a rocket launch. It is an entire planetary scale operation. You need spacecraft capable of surviving years in deep space. You need life support systems that can recycle air, water, and waste with near perfect efficiency. You need radiation protection, medical facilities, food production, energy generation, communication systems, landing vehicles, surface habitats, and a way to bring everyone back home. None of this exists as a complete, tested system. Every piece must be designed, built, launched, and integrated together. And because there is no room for failure, everything must be redundant. Backup systems for the backup systems. If a water recycler fails on Earth, you fix it. If it fails on Mars, people die. That level of reliability is incredibly expensive. Even conservative estimates place the cost of a single human Mars mission at hundreds of billions of dollars. Some estimates go as high as $1 trillion. That is not a typo. $1 trillion is more than the annual budget of most countries on Earth. For comparison, the entire Apollo program, which put humans on the moon, cost roughly $200 billion in today's money. And the moon is just 3 days away. Mars is 9 months away, with no possibility of rescue. Once astronauts leave Earth for Mars, they are on their own. You cannot send a rescue ship. You cannot bring them home early. Orbital mechanics do not allow it. Their trajectory is locked in. If something goes seriously wrong, there is no second chance. That means every mission must be prepared as if it is the only chance those astronauts will ever have. And all of that preparation costs money, a lot of money. Then there's the cost of launching mass into space. Everything needed for Mars, habitats, food, water, fuel, equipment, radiation shielding, has to be lifted out of Earth's gravity well. That is one of the most energy-intensive things we can do. Even with reusable rockets and modern technology, launching large amounts of mass is still extremely expensive. Every extra kilogram adds cost, and Mars missions require enormous amounts of mass. You cannot send people to Mars with a small, lightweight spacecraft. You need thick walls for radiation protection. You need large volumes for living space. You need tons of supplies. And you need fuel, not just to get there, but to land, take off again, and return to Earth. Some mission designs rely on producing fuel on Mars using local resources. This sounds clever, but it means sending even more equipment ahead of time. Chemical reactors, power generators, storage tanks, and spare parts. If any of that fails, the crew may never come home. So you have to overbuild everything. More mass, more launches, more money. And what do we get in return? From a scientific perspective, robots already do an incredible job. Robotic rovers can explore Mars for years. They do not need air, water, or protection from radiation. They do not get tired. They do not get sick. And if one breaks, we build another for a tiny fraction of the cost of a human mission. Robots can drill, analyze soil, search for signs of ancient life, and send back high-resolution images and data. For pure science, robots are far more efficient. So the value of sending humans is not really about data. It is about symbolism. It is about inspiration. It is about saying that humanity has reached another world. And while that is powerful, it is also incredibly expensive. Societies have limited resources. Every dollar spent on Mars is a dollar not spent on healthcare, education, climate change, infrastructure, or poverty. When you are talking about hundreds of billions of dollars, those trade-offs become impossible to ignore. Would people be willing to pay that price? Maybe once. But would they be willing to keep paying it? Because one mission is not enough. To make Mars truly meaningful, you would need multiple missions, ongoing support, and eventually some kind of permanent presence. That means spending enormous amounts of money for decades. History shows us that political priorities change. Governments change. Budgets change. Long-term space projects are often the first to be cut when money is tight. So even if we launch a Mars mission, sustaining it would be incredibly difficult. And this leads to an uncomfortable conclusion. The physics makes Mars hard. The biology makes it dangerous. And the economics make it almost impossible to justify. Yet people still dream of it. So why does the dream refuse to die? Despite all the dangers, all the costs, and all the physical limits, the idea of humans going to Mars still captures the imagination. There is something deeply human about wanting to step onto a new world. It is the same impulse that pushed our ancestors across oceans, through deserts, and into unknown lands. We are explorers by nature, and Mars represents the ultimate frontier. When people talk about becoming a multi-planetary species, they are not just talking about technology. They are talking about survival. Earth is vulnerable. Asteroid impacts, climate change, pandemics, or even our own mistakes could one day threaten civilization. Having humans on another planet feels like an insurance policy for the future of our species. Mars, being relatively close and somewhat Earth-like, seems like the obvious choice. It has a day length similar to Earth's. It has seasons. It has ice. It once had rivers and oceans. In the distant past, Mars may even have supported life. So emotionally, it feels like a place we could belong. And then there is the power of inspiration. Space exploration has always pushed science and technology forward. Satellites, GPS, medical imaging, materials science, computing, Many of these advances were driven or accelerated by space programs. Sending humans to Mars could spark a new wave of innovation that benefits life on Earth. It would also create a powerful global moment. The first humans on Mars would be watched by billions. It would remind us that we are not just citizens of individual countries, but members of a single species living on a small, fragile planet. These are not small things. But inspiration does not cancel out physics. The problem is that Mars is not the American frontier. It is not a place where you can just arrive and start building. Every second on Mars, humans must fight the environment just to stay alive. There is no air to breathe, no water to drink, no soil to farm, no protection from radiation. Everything must be manufactured, recycled, and maintained by machines. A colony on Mars would not be a new civilization. It would be a life support system with people inside it. And that system would have to work perfectly forever. One major failure could end everything. This is why comparing Mars to past human migrations is misleading. When humans crossed oceans or moved into new continents, they entered environments that could still support life. They could breathe, drink, and grow food. Mars offers none of that. It is fundamentally hostile. So the dream of Mars is not about colonization in the traditional sense. It is about extreme survival in one of the harshest environments imaginable. And that raises a serious question. If we have to spend enormous amounts of energy and money to keep a few people alive on Mars, would it not make more sense to use that same effort to protect and preserve Earth? Earth already has everything we need. It has air, water, fertile soil, and a magnetic field. It is perfectly designed for human life because it is where we evolved. No planet we ever reach will be as easy to live on as Earth. So perhaps the greatest lesson of Mars is not how to leave Earth, but how rare and precious Earth truly is. Still, the dream continues. Engineers build new rockets. Scientists plan future missions. Private companies talk about cities on Mars. The vision is bold and exciting, but the gap between the vision and reality is enormous. And that brings us to the final question. What does the future really look like? When we strip away the excitement, the science fiction, and the heroic imagery, what remains is a cold, hard reality. Space is not welcoming. Mars is not a new home waiting for us. It is a frozen, irradiated desert that requires enormous effort just to keep a single human alive. And that reality is not shaped by politics or imagination. It is shaped by physics. The laws of nature do not bend to human ambition. You cannot escape radiation by wishing it away. You cannot reduce energy requirements just because a mission is inspiring. You cannot make human biology suddenly adapt to low gravity, cosmic rays, and isolation. These are not problems that clever engineering can magically erase. They are fundamental limits imposed by the universe itself. Yes, technology will continue to improve. Rockets will become more efficient. Life support systems will become more reliable. We may even develop new propulsion methods or better radiation shielding. But progress in physics is slow and incremental. We do not leap past thermodynamics. We do not rewrite nuclear physics. We work within their boundaries. And within those boundaries, Mars remains brutally difficult. Even if we manage to send humans there once, sustaining a long-term human presence would require an endless flow of resources, equipment, and money. A Mars base would never be self-sufficient in any meaningful sense. It would depend on Earth for technology, spare parts, expertise, and constant support. If that support ever stopped, the colony would fail. So the idea that Mars could become a true second home for humanity, a backup civilization, is far more fragile than most people realize. That does not mean we should stop exploring. Mars is one of the most fascinating places in the solar system. It holds clues about the history of planets, the evolution of atmospheres, and the possibility that life once existed beyond Earth. Robotic missions should continue. In fact, they should expand. We should drill deeper, map the underground, search for ancient microbes, and learn everything Mars can teach us. But humans do not need to be there for that. Robots are not limited by radiation, gravity, or oxygen. They do not need food. They do not suffer from isolation. They can work for decades in conditions that would kill a human in minutes. From a scientific and practical perspective, robotic exploration makes far more sense. And that leads to the final, uncomfortable conclusion. We may go to Mars someday. We may plant a flag, take photographs, and prove that humans can survive there for a short time. But a sustainable, large-scale human presence on Mars, a real colony, a real civilization, is likely far beyond what physics, biology, and economics will allow in any meaningful time frame. Mars is not the future of humanity. Yes. The universe is vast and beautiful, but it is also unforgiving. Life is rare. Habitable worlds are precious. We already live on one of the best planets we could ever hope for. Perhaps the greatest lesson of Mars is not how to leave Earth, but how much we should protect it. Still, science advances. Generations change. New ideas emerge. Maybe in 100 years or 200 years, technologies we cannot yet imagine will make Mars more accessible. Maybe future humans will look back at these doubts and smile. If that happens, it will be a wonderful thing. But based on everything we know today, the physics of radiation, the biology of the human body, the limits of energy and propulsion, and the enormous cost of operating in deep space, Mars remains one of the most difficult destinations imaginable. The dream is powerful, but the universe is stronger. And for now, Earth is the only home we truly have.